Hello everyone. Today we'll be discussing about bubble sort in this session. So again, the name itself says that it is sort. Sorting is nothing but arranging your array. So in the particular order, arranging array in a particular order. So we are applying the technique called as bubble sort. Okay, what do you mean by bubble? So I think you might have seen this in your water. What water effect says is, for example, if you have a water and inside this water, if any bubble is created, what happens? Bubble is less weighted. So I can say if the bubble is generated, that bubble comes up initially. The bubble goes onto the top every time. So bubbles which are present here always goes onto the top. They won't reside inside your water. They goes onto the top. The same concept is applied here. Here either you can take the maximum element or minimum element. Usually I'll be applying the logic of maximum element, and that maximum element is pushed to the end of the array. I'm sorting this in the ascending order, so I'll be pushing the large elements, and large elements I'll be placing at the end of the array one by one. I'm considering the large element as a bubble, and I'll be pushing to the last most position of this particular array. How do we do this? We will be discussing about this. We will take this particular array. First and foremost thing, what we have to do here is we need to understand, we need to take the first element here. I'll be taking this particular first element and I'll be comparing this first element with the second element. Now let's compare the first element with the second element. Whether this particular element is greater than this particular element. That is, I'll be considering with one loop, and I'll just check whether 5 is greater than 3. Yes, 5 is greater than 3. When the 5 is greater than 3, I'll just swap these two elements. What happens? I'll just remove this 5 and I'll put 3 here, and I'll remove this 3 and I'll be putting 5 here. That means these two elements are swapped now. After swapping these two elements, again I'll compare now the 5 with 1. I'll be comparing 5 with 1 now. So 5 is the element which is present at this particular index. I'll be comparing 5 with 1. Which is maximum? 5 is maximum. If this element is greater than this element, we need to swap both. So I'll be swapping now. I'll remove 5 and I'll be replacing this with 1, and I'll be pushing 5 here. This is what I told. The largest element should go to the, I can say the corner of your, I can say the last indexes of your array. Okay. Now again, I'll check the 5 with 2. This is an unsorted array, which I'm trying to sort by using the, I can say the technique of bubble sort. Now you see 5 and 2. 5 is greater than 2. When it is greater than 2, again, I need to replace this 5 with 2, and this 2 will be replaced by 5. Now the largest element is present at this particular index. So you can check, compared to all other elements, this is the greatest element, and the greatest element is present at the one corner of your array. I can say it as large index. I am comparing this as the highest position. How the bubbles comes to the, I can say the top of the water. Similarly, the largest element has come to the top of your array. Okay, the last element of your array. Now this element is already sorted. I need not check this again. Now our task is to compare or the sort these particular three elements. This is one iteration. I did it with one iteration. Now I'll check the other iteration now. The second iteration I'll take now. For these four elements, I'll go with the second iteration now. Let us take this iteration now. What I'll do, again, we have an element called as 3, 1, and here the element present is 2, and here it is 5. 5 is already sorted. I need not worry about this. I need to compare only among these three elements. I need to compare only among these three elements. Let's say I'll compare now 3 with 1. 3 is greater than 1. Yes, the condition is true. 3 is greater than 1. So I need to swap these two elements now. Now I need to swap these two elements. So I'll just remove 3 and I'll be placing 1. I'll be removing 1 and I'll be placing 3. This is nothing but swapping. I did swapping now. Again, I need to compare 3 with 2. Again, I need to compare 3 with 2. I'll just compare 3 with 2. Yes, 3 is greater than 2. So I'll be replacing this with 2 here, and 2 is replaced with 3. I need not compare with this particular element now. Now my current element is this. I need not compare with 5 because 5 is already greater. I have pushed it in the last iteration. So we stop here. And now you can observe this is also a largest element now. I need not swap again this element also. I need not compare. This iteration is completed now. You can observe the next largest element has been pushed to the next index. Again, I'll take this array once again, because we need to proceed for the rest of the elements. Now 3 and 5 are already sorted. The rest elements are 1 and 2. We need to check whether 1 and 2 are sorted or not. I'll just check 1 and I'll compare with 2. I'll compare with 2 whether these two are sorted or not. These two are sorted or not. So 1 is greater than 2. No, the condition is false. It is already sorted. No need to swap. So it stops here. So how many iterations we have taken? We have taken three iterations out of four. So we have taken three iterations out of four elements. If four elements are there, so how many times I need to continue this operation? We need to continue three number of times, so that I can say that if I'm starting my loop with one, I need to end it by n minus one number of times. That is outer for loop. Outer for loop which I am using for number of iterations, and inner for loop which I am using for comparing among these elements. So inner for loop which I am using, I am comparing for these elements. You can observe when the I value was 1, I have compared for all the elements. I have run it for three number of times. When the I value was 2, the two comparisons I made. When the I value is 3, I made only one comparison. So that's how your inner for loop is just ignoring one I value. When I value is 1, so or else if I take I value as 0, it is doing for all the iterations. If the I value is 1, one iteration, one element is left. One element is left. When the I value is, I can say two elements are left. You can say we are not comparing two elements. Depending on this particular logic, let's try to write our loop so that you will get a clear idea about it. And then we'll go and solve this particular program. Okay, what I'll do, so I'll use my outer for loop. I'll write my outer for loop as, I'll say I value. If I'm starting with 0, how many number of times it has to run? It has to run for, I can say, actually, if you are starting with 1, if the n value is 4, we need to run for only 3 number of times. If I'm starting with 0, that means it should run for 0, 1, 2 number of times. So 2 I'll get, and if n value is 3, so I can say it should run for only 1 number of times. You can observe here, the n value is 4, we need to run for 3 number of times. So I'll just give my I value should be less than n minus 1, and I value should be incremented. What I'm trying to do is, if the n value is 5, so it should run for 0 to 3, 4 number of times. If the n value is 10, it should run from 0 to 8, sorry, 0 to 9. So that means I can say it as 8 number of times. 0 to 8, which is 9 number of times. So that's it. So that's how the loop will be running. This is my outer for loop for number of iterations. Then what we should do for inner for loop? J value I'll be saying again, I'll be initializing with 0 only. If I'm initializing with 0, you can observe that when the J value was 0, it was how many comparisons it was making? Four elements were there. 1, 2, 3, 1, 2, and 3 comparisons it was making. So you just understand. So J value was making 3 comparisons. I can directly write this J formula as J should be less than n minus I minus 1, and J is incremented 1 by 1. What I'm trying to do here, you just try to understand. When n value was 4, the n value was 4. Let us assume n value was 4. How many comparisons we made? 3 comparisons we made. So you can observe when n value is nothing but the number of elements value. So how did we make the comparison here? First comparison, second comparison, and the third comparison. So we made 4 comparisons. I value was 0. I was just subtracting 4 minus 0 minus 1. When the I value was 1, we were making only 2 comparisons. So that I made it as 4 minus 1. I value is 1, 1 minus 1. When the I value was 2, how did we make this comparison? N value is 4, 4 minus 2 minus, I can say it as 1. You can observe that. So how many comparisons we are making? Only one comparison we are making here. So that's how I have written a generic formula here. That is, it should be J should be less than n minus I minus 1, where J is incremented incrementally. And inside this, we can put a condition and we can compare for every element and perform the logic for, I can say it as swapping. We'll see that inside our, I can say the program. Let's go to the program and start solving it. Okay, so this is what the program they have given. Write a C program to read n integer numbers and arranges them in the ascending order using the bubble sort algorithm. We need to apply the concept of bubble sort algorithm, which we have discussed just now. And then we have to display these elements before and after sorting. We need to display the elements before and after sorting. That means we need to read the elements first from the user, and then we need to perform the sorting. Let's see what exactly it is saying. See, it is saying this test cases has given like this. First, let's start coding for this. I'm just including the header files here. So after including the header file, the next task is we need to write a main function. I'll just write the main function. Inside the main function, I'm just reading the n value. So before that, I need to declare n. So I have declared n. So I'm just asking user to enter the n value. So I'll just say n colon. That's how they have given. So I'm just giving n colon. Now I need to read that n value. So I'll just read that n value since it is an integer value. So I'll be reading with the format specifier percentage %d. Now I need to declare an array. So I'll be giving my array name as a. So I'll be giving the size as n because n number of elements only we are going to read. And now we have to ask for the elements. So I'll just ask the user to give the elements. I'm asking elements. I'll use a loop. I'll just declare an I variable. I'll be initializing with 0 and I'll read all the array elements into the array called as A. So I'm starting my index with 0 and ending before n. So that's how our array elements will be read into the array and will be stored into the array. So since all the elements are integer elements, I'm using the format specifier as percentage %d and I'm storing it to the array called as A. And specific index, I'm giving it as I. So this is how we have read the elements. Now I need to display the array elements. For displaying the array elements, I'll just write a logic. So I'll just, after that they're saying before sorting. So I'll just write this printf statement. I'll just write this printf statement and print the elements before sorting. I'll say it as before sorting. We need to print the elements. Since before sorting also I need to print the elements, after sorting also I need to print the element. So what I'll do, instead of writing the code twice, before the main function, I'll write a display function and I'll call the display function. That's it. So void display I'll be writing. So instead of writing the code twice, I'm using the I'm taking the benefits of, I can say, this functions approach. I'm just taking the benefit of functions. I'm just passing two parameters to it. So I'll just call the display function here. And this is the function definition which I'm writing here. So here I'll call the display function. For the display function, I'll be passing two parameters. One is a value and other one is n value. So that I'm receiving it here and I'll be printing it here. I'll declare one variable I. So I'll use a for loop just to display it. I'll be starting my array index with 0 until the last element. I'll be moving across every element. I'll just print the elements one by one with spaces because you can see it is printed with the spaces. So I'll just say, so format specifier is percentage %d and again I'm giving a space. I need to print every element. So of that, so I need to print whatever is present in the array of I. After doing that, so they have also told there should be a new line character. So I'll just print if I'll say there should be a new line character. This is just displaying the array. This function which I have written is for displaying the array elements. Now, before sorting is done, but now after that, we need to perform the sorting approach. As I discussed about the sorting, I'll be starting my index I again. So I'll be initializing with 0. As I told, it should end with n minus 1. It should end before n minus 1. And I value I'm incrementing step by step. Again, similarly, we need to do for j value. As we have discussed, j value should start with 0 and j's termination condition. I have discussed about this in the previous explanation. It is n minus I minus 1 because the last values we are not making use of, because once the highest value has been moved to the, I can say, the last index, that for the next iteration we don't have any role to play in sorting that particular element because already that particular element will be sorted. So that's why I'm just giving n minus I minus 1. Again, I'm just incrementing the j value. So now comparison we need to make. I have discussed about this comparison. If a of j is greater than a of j plus 1, so then our task is to swap the elements. So for that, I'll be declaring one temporary variable. So I'll be making it as int variable called as temp, and for which I'll be assigning a of j value. And again, a of, this is swapping logic. I think you all know about it. So where a of j will be equal to a of j plus 1. And the next a of j plus 1 should be replaced with your temp value, which I have just temporarily stored. This is swapping happens here. So after completion of all these three loops, swapping is done. After swapping, we need to print saying that after swapping, what are the elements? Let's do that. So I'll say after swapping, sorry, after sorting. So all the elements to be printed. So I'll just go here and I'll call this display function and I'll be passing this new array to it, the array sorted array to it. I'll just call the display function. Now I'll be passing for the display function the same. A, and I need to pass the n value as well. Let's see now what is the answer I'm going to get. So let's run and see for a few elements if it is working fine. It is asking for the n value. So n value I'm giving it as 4. It is asking for array elements. I'm giving 44, 22, 66, and 11. Let's see. So before sorting, it was 44, 22, 66, and 11. And after sorting, it is 11, 22, 44, and 66. This test case is correctly working. Now I'll submit and see whether it is working fine for my submissions for every test cases. Yes, it is working fine for every test case. This is how we perform the bubble sort. Here, only one thing which you need to understand here is how many number of times I iterate and how many number of times we make a comparison among the inner elements. Okay, if you understand this, then automatically you can write the bubble sort. It's a simple logic. So as I explained there, so you have to understand that and you have to write it. So thank you. If you have any doubts, you can revert back to us. So we'll be clearing that.